Thank you so much. Everything working? Yeah, thank you for having me here and giving me the opportunity to what I call Borderlands new approaches to the LBK on its western margin. So we are looking at the earliest Neolithic of Central Europe in its more northwestern part. Just to broadly soon you'll see. To orient you, so the whole talk will be structured in two sections. In the beginning, I will give you an overview of the early Neolithic in the Rhineland, or more specifically, the northern Rhineland, with a focus on settlement dynamics and land use, to then kind of leave this perspective and see and ask what position this area takes within the whole LBK context. And on the way, introducing very briefly several large-scale approaches regarding population dynamics, suitability, adaptation, modeling, and raw material networks that we have been applying and developing within this larger research question. For one, I already have to apologize, as I have this very specific view on things regarding settlement dynamics and land use. So you will not see a lot, if any, nice finds and features, but you will see a lot of graphs and maps, especially. So if you expected something else, I'm sorry, but at least I made them. I tried to make them colorful so that you'll enjoy them. And yes, so this is what we are looking at. Do I have to admit the person, or?
No, I
Okay. So, starting off, where are we at? This will not be brand news to you, but to get everybody on the same page, we are looking at the early Neolithic, or the earliest Neolithic in Central Europe, these first farming communities in Central Europe, which had some, let's say, some kind of formation phase in the Hungarian plains in the 6th millennium BC before they spread rather rapidly by the mid of the millennium, passing the Alpine Carpathian corridor into the Central European plains, where they constituted what is first known as the earliest LBK in this smaller region, before this then was overlaid by the younger phases, spreading and reaching their maximum distribution, reaching from the Paris Basin up to here, near the shore of the Baltic Sea and the shores of the Black Sea, which I very rudely cut off here, as we are centering more on the western part. They did this very rapidly. They reached around the end of the 51st century BCE, their maximum distribution, and then ended more or less abruptly, or not abruptly, the phenomenon ended that we recognize as LBK. They carried the whole Neolithic package with them, so they practiced husbandry with cattle, sheep, and goats, and pigs. They cultivated mostly cereal, and they are overall perceived as rather homogeneous, defined or recognized by their common way of treating the dead, often in this crouch position, of course, with the decorations and the eponymic decorations of their pots with this linear bands, and of course, the very enigmatic way of building their longhouses, which is probably the most common feature and unifying feature across the whole distribution area. They centered their whole economic system on, not exclusively, but often on the rust patches distributed into the Central European plains, which leads to this really patchy settlement agglomeration areas. And this is something that we take seriously. So we don't believe that they spread evenly into the whole Central European plains, but really centered on these areas. And we take these areas in between the settlements agglomerations seriously, where there wasn't a lot of activity going on there. So not all of these holes here in between are due to research history or the lack thereof, but are also mirroring the true settlement patterns. We're now zooming in into the Rhineland a bit, which is here in this area. So Frankfurt is around here, and up here is the border to the northern Netherlands. And in yellow, you see the settlement areas of the LBK there. And you can see they're all clustered on the western part, or the western side of the Rhine, in the what is today the drier areas of precipitation. We are slowly approaching our key area. We are now coming to the northern part, to the Jülich-Zülpicher Löss Plateau, which is here, which is this big agglomeration of Löss soils, which of course, because of their really favorable conditions, were always settled very densely also in the LBK. And then we are entering even further in this northern area, which is, yeah, this one up here, coming to the area where there is this big lignite mining, coring or mining going on. We have, as these are getting more important, I will show you a bit what it looks like. We have here the Inden Tagebau, the Inden mining area, the large Hambach and Garzweiler 1 and 2 up here. And this lignite mining in the area was always accompanied by very dense archaeological work, very closely latest with the 70s, with the beginning of the 70s, when the Siedlungsarchäologie at the Aldenhovener Platte project was established there. So settlement archaeology on the Aldenhovener Platte. The Aldenhovener Platte is in reality this really small part of it. Here are some pictures. This one is actually like from the area, from the time horizon. But you see here these large excavations going on right at the edge of the mining, with these large excavators here in the back, and here is this big house floor plan. I don't recognize any of these people there, but maybe Harald. And what you can see here is that these, of course, they were very, very finely grained in these very in-depth excavations, but they are ultimately rescue operations because the whole area is gone by now. So there's nothing left there. They're totally dug away to get to the lignite mining. Same area now. This is an aerial picture I pulled from Google Maps or Google Earth, I don't know, but we see what it looks like from the air. The Inden mining area here, Hambach and Garzweiler, and actually in Inden they're starting to pull or to fill it with water, or they're starting the process to fill it with water from the Rhine. And Hambach is also, the process is supposed to start, I think, in the next 10 years. The filling up of these areas will take about 50 years with water, making them Hambach the second largest lake in Germany, which I think is extraordinary if you think about the size of these holes and what is happening there. This is not what we are talking about. We are talking about the LBK in this area. So what you see here, Inden down here, this is the area that is covered here. And you have this big settlement agglomeration here with Langweiler 8, the famous Langweiler 8 there, the Merzbachtal. You have up here around these areas another settlement agglomeration with Königshofen. Up here, Kückhofen, which is also very famous, is in between these areas, and then scattered across more settlement sites. Up to now, we have in the area over 50 that have been evaluated archaeologically, very or in depth evaluated. The latest one, which has been recently published now by Barkowski and Peters, I think this is a bit older because this is referring to the thesis, but there are now 25, I think it was published, a good book, is Arnoldsweiler. And Arnoldsweiler is this textbook example of an LBK settlement in this region, as it displays a large settlement area. There were 51 house floor plans there. There are 4 wells within the settlement area, and one of them displaying this nice wooden construction. To the north of the area, we have a large cemetery, and to the southeast, we have an enclosure showing up in which another 16 house floor plans were discovered. That we have the cemetery is somewhat special, as we have, well, in the region, due to the acidity and the decalcification of the soil, we actually do not have well or good preservation of organic materials. So it was long believed that it wasn't possible to find really large-scale cemeteries there, but this changed somewhat. So we have 6 cemeteries in the region now, with Altdorf with 120 graves situated here, and Arnoldsweiler, which is about 230 graves here, displaying, in depends on who you ask, okayish or sufficient or good bone preservation to really do some in-depth analysis there. We also, and then again for the cemeteries, it was also long believed that they only showed up by the end of the LBK settlement activity in the region, but this is not true, as you can see, because it goes through the whole sequence. We have this nice well in Arnoldsweiler, which is together with the 3 other ones that are in the area. You can see that they are all dating more or less to the end of the settlement sequence, with Arnoldsweiler here dendrochronologically dated being the oldest one of these, but they're all at the end of settlement sequence. Yes, and we have the earthworks or enclosures, which is also a very common find in the area. We have here in this small area 10 which have been analyzed in depth, with Arnoldsweiler being the youngest one, and which are in synchronous with the building of the wells, in the meaning that they all, by the end of the settlement dynamic or settlement history, these enclosures were built. And of course, through this long research history and in-depth research history, we have a good knowledge about the procurement strategies coming or going on in the region, especially relying on the Reichhold or the Maastricht flints coming from the west, and an ongoing growing catalog of pot and band types in the area, which are used to have a local typochronology, bringing all this information together. We think we can analyze the local population dynamics very closely. So what is good in terms of the lignite mining activities, you can see here again the borders of Inden in an older version, so it has changed very much now. But actually within this region, which is completely gone now, really all of the archaeological sites have been reported there. So I think in terms of absence or presence of sites in the locality, this is a maximum of archaeological knowledge that is reachable, because the whole region without doubt was excavated. So there's nothing left there and everything was reported. And using all our knowledge regarding the typochronology and the overlapping of houses, using the much discussed Hofplatzmodell, which I will not go into depth today, but we can see the general pattern, what is going on as start of settlement activity around the end of the 54th century BCE, with a more or less gradual increase of settlement activity. And it did, but reaching its maximum around the mid of the 51st century BCE, before then a more or less steep decrease happened, leading to the end of what we recognize as the LBK. You can see also that there is differences in the specific settlement history of single settlements, as we have Langweiler 8, who runs through the whole time period, but we have also smaller settlements popping up and disappearing again, or popping up and coming back again. With some very simple geostatistics, in this case, again, regarding this area, using Thyssen polygons to calculate the maximum available area per settlement, you can distinguish, or you can calculate like a maximum household density reached around here, which we believe arises to around 1 household per square kilometer, which is the maximum. So this is a maximizing approach, but this is what we believe was reached here around the 51st century BC. We were only looking at the small area here. Now a few more settlements are included in this. and you can see that the general pattern stays the same, and you can see more clearly maybe what I mentioned, this differences in settlement history. We have Langweiler Ach with this long occupation. We have Arnoldsweiler, which seems to be, which has lacks or which has holes, gaps in between the settlement history. And we have to the end of the settlement, the arising of much smaller settlements coming up. This is something that we observe also on other areas of the LBK distribution. Now we are leaving the Rhineland and looking at a little bit of larger developments. We have here the what Detlef Rodenborn and his working group are doing and calculating. We have this early start at the earliest LBK, making it easier earlier than in the Rhineland. In Württemberg, with this steady growth coming to a peak and a very sharp decline. And also the Kiel group, what they are calculating for Vrable is probably wrong, as you can see, but we have this general pattern. And if we take these patterns seriously and believe that they really show a more or less similar pattern in the development across the LBK, we of course have to ask us what led to that. So what are the driving forces of this really rapid increase and influx of LBK people into the Central European plains, and what led to their rapid end, whatever it means. The problem is, though we think that we have on a very local to regional level a detailed knowledge of what is happening, we do not know that on a large scale. We can only see very large trends. We have here a map of the oldest LBK using the database by Annalena Fischer. You can see here how it ends, east of the Rhine. The Rhine is well outside of this distribution area. And here the agglomeration areas in red of the younger phases. And it is generally or often believed that you have from the starting of the LBK coming here from the Hungarian plains, this wave-like explosion of people moving into the land driven by a high population growth, and through reaching local ends of carrying capacity had to spread further into the landscape, and this showing up this larger patterns. Yes, and to explore these differences maybe in the oldest LBK and the full LBK, as it is often believed that after the spread of the oldest LBK, there was a general halt in this expansion, and implying that there was some kind of adaptation process that was going on. Because these people coming from the southwest had to adapt to the local environment, and once they adapted, it was then overlaid by the younger phases. In order to analyze this notion further, we have been working with meteorologists, with modelers from meteorology within the HESCOR project, which is ongoing right now. HESCOR is a very large project bringing together meteorologists, mathematicians, geography didactics, prehistoric archaeologists, and literature studies from MESH. MESH means multidisciplinary environmental studies in the humanities. So they are for giving us this theoretical groundwork. And here, this is a sub-project that we from Prehistory, together with the modelers from meteorology, are developing. It is based on the Our Way model or human existence potential model that is ultimately a niche construction model or a species distribution model. It is well established by now. It was developed within the CRC Our Way to Europe from 2009 on, with the ultimate or with the initial goal to model early human expansion from Africa into Europe. And we have been adapting it to these first so-called sedentary societies as a niche construction model. It basically analyzes the distribution of a given population in relation to variables that we feed into it, to then calculate suitabilities or potential in a landscape. So it is, which is important, not a predictive model. So we do not think that when we look at the given distribution of the population, or the site distribution, and define what their preferences were within areas that have high potential, that they must have been there. But it shows us the niche of a population, where they like to live, and of course also areas where they didn't, but potentially have a high suitability. Let's see. I've moved on here.
It's okay.
Okay. Yeah. I will not talk about the model itself much, because it's of course a lot of math, and I'm not the expert in that anyway, as our meteorologists were coding that and developing that. Just to give you a short introduction of what we are doing, we are using paleoclimatic maps, which are available from the Paleoclim organization website, and now newly the CHELSA data, downscaled to 10-kilometer resolution. We calculate then the potential of these different bioclimatic variables for the earliest LBK, using again Annalena Fischer's database, and then the sites for the full LBK, which is an agglomeration of different publications that we put together. And by the end, we add also soil fertility value, which is based on modern day soil maps. Just to give you a broad impression what we are looking at, this paleoclimatic data is available for 19 different variables, bioclim variables, which encompass, for example, the annual mean temperature or the mean diurnal range, as well as annual precipitation, but also things like precipitation of the warmest quarter. So this is the data that is available for the mid-Holocene, from, as I said, Paleoclim and now the CHELSA data. And what we did in regard to the soil quality, we took the soil quality indices from the German Ministry of Agriculture and combined them, or I would say our palynologist Oliver Kern combined them with the European soil database, and transferred then these using the soil classification reference base into, so we transferred the data from Germany into the whole of Europe and exported it as a raster, giving us values from 30% to 100% of soil quality of today's soil. This is, as we've seen, a lot of input, as these 19 different paleoclimatic variables. To reduce the complexity, we calculated the collinearity between these variables, and always chose, after defining these 4 clusters or other clusters, always defining one variable that we actually put into the calculation. But actually, we found out now that it is, although some of these variables are very closely correlated, it still makes a big difference which you choose of them. So this is why we actually executed now, I think, 57 experiments using these different sets of variables to calculate the potential of the geographical area for a given time horizon. You can see here 6 of these experiments, and what I'm presenting here is like the median value of these different calculations put together. This is the HEP, so the potential of the European landscape for the earliest LBK, and white we see the size of the earliest LBK. So the values in red show areas that display the same characteristics in terms of the variables that we are looking at, than the areas that the earliest LBK settled on. And there is a lot to discuss, which is a lot of interesting facts, like here in Polish, why this is all red. And of course, these artifacts up here, we can see very clearly that we also have something in the data, in the underlying data, that doesn't apply for the LBK. So we have probably artifacts in there, also in the ground lying data of the paleoclimatic, because this is something that is not well discussed, but all this data is of course simulated. This is not any, the paleoclimatic data is not built upon pollen or something. This is modeled paleoclimatic data. So we have to discuss the single finds, but as we are today focusing on the Rhineland, I will only show this particular thing. We're looking here. Here is the Rhineland. This area here, we see the in white these earliest LBK and this empty spot here. When we put now the sites of the full LBK on the map of the earliest LBK, we can see how they really move into this area here. The picture changes when we look at the HEP values, the potentially values of the whole LBK as it gets much wider. But as France is now included, but the initial picture stays the same, that especially in course of the Rhineland and also here down here in Alsace, we can see how the younger phases of the LBK really moved into areas that were already in the niche of the earliest LBK. I'm standing here and waiting because it doesn't always react. So if we look at the data more closely, you can see here, this is the distribution of the sites of the earliest LBK in red and in the full LBK in blue on the calculated HEP values. And we can see the tendency, the red is the earliest LBK, as I mentioned, that it is a bit more narrow and actually focusing more on high potential values, and that the full LBK might have enlarged their niche potentially. But still it stays the same. You're moving in a bit with the borders of the agglomeration areas, that for the LBK, they really moved into these areas that were already within, or that were already in the manifestation of the earliest LBK. What does that tell us? It tells us that it wasn't an adaptation process that had to take place between the earliest LBK and the full LBK. It was already within their possibilities to move in these new spaces. And this also tells us something about the pressure or the driving force behind the population expansion into the European plains. As you can see here, there was always enough space to move into, and in these core areas of earliest LBK and younger LBK, it was also possible to enlarge the settlement areas. So it cannot have been population pressure in itself that really drove these people into new areas, but something that is potentially ingrained into their society. So if the population pressure and the limits of carrying capacity wasn't the driving force in this initial expansion, what about when they reach their maximum population density? Because this is also discussed, what led to this crisis scenario at the end of the LBK. And a lot of people think it might have been really population pressures that got to the end of their economic system. Which you see here, because we have this really steep decrease in these in the houses, or what we recognize as the LBK. What we did in an earlier project, the LUCIS project, standing for Land Use and Climatic Influences on Fluvial Systems. You always need a great acronym for your projects. We developed a model to calculate the maximum amount of potential of agrarian areas, agriculturally used areas for the Rhineland, which was driven by the human energy demand, so the maximum amount of people that have to be fed within the system, and the energy derived from animal products and from vegetable foods. Again, I will not get into much detail there. It is defined by, of course, a number of people, by the seeds, in what relationship the seeds were, and the number of identified specimens, in the tradition of a lot of similar calculations that have been going on starting with Greg in 1988, and then also, of course, Ebersbach and Schade for the Mördener Bucht, and also more recently from Baum et al. From 2022, which all had a very similar approach to these things to calculate these maximum areas. We used it to really see how the how space must have been used in accordance to if you have more cattle husbandry, because this is actually the defining value in terms of wood pasture and pasture that you need, because you need large amounts for the cattle. You also have sheep and goats, but they don't need that much space and they can roam around with the cattle. And how if you increase the amount of animal products in your food, how that influences the use of space. And especially what is telling is that the size of fields is always very low per household. We actually calculated this maximum, with the maximization process, as we thought, or we implemented something of fellow dynamics. So a field was used for 15 years, and then it was laid still for 75 years. Of course, in the data of the LBK, we don't see that. But we wanted to have, if you have these very long processes, what does it mean if you have on a large scale these fellow processes in there? And what we can see here, very short, is that in what we believe they had most of their input was from plants. If you think of a 5% energy in the food coming from animal sources, they would have needed like a household around 5 hectares of fields and around 17 hectares of wood pasture. And you can play around with the data and drive the animal sources, the input of animal sources up. And you can see how the changes actually then in that moment, the field space, of course, diminishes, and the needed wood pasture really goes up. But if you transfer these values into like the largest settlement areas that are calculated using the site density, you can see that the limits of the system is really reached only when you have very, very high energy inputs from animal sources, which we think is not probable for the LBK. So it seems that it was always possible to enlarge their fields, to enlarge their animals, or the number of animals they had, and especially also if everything else fails, it always had the possibility also to go hunt and use the fruits of the woods around them, which were also very abundant, because using wood pasture probably opened up the woods, making hazelnuts, making berries much more abundant in these areas, besides being good for the oak because they have more lights. So from the point of view of our approaches and from the Rhineland, it doesn't seem that there was an upper limit reached within the settlement dynamics of the LBK. And other people have also noticed that. This is a study from Pendant et al. From 2022. And they also came to the same conclusion that the upper limits were reached. Look at my time, okay. That it was not the upper limits that were reached in this area, but probably something else led to the end of the LBK as we recognize it, which is possibly due to some degradation of networks going on there. Networks in terms of connectivity networks, of mobility networks, people talking to each other and developing each other further. And this is the last bit that I will present. We are again looking within HESCOR together with mathematicians at these mobility networks with the goal to simulate probabilistic mobility networks for large-scale migration events from the Magdalena, for example, which took place in the course of several thousand years between 20,000 and 15,000 LBP, which resettled the European plains after the last glacial maximum, but also for the LBK. And we want to when we are combining mathematical proximity networks or proximity approaches to connect regions of the LBK with actual archaeological data, in the hope that we overcome this way these limitations or these modeling approaches where we only see this wave-like font, to the introduction of archaeological data already in the groundwork of the modeling. We want to implement the possibility of especially leapfrog, for example. And the idea behind it is that if you have the distribution of the LBK and we have the distribution of raw materials flowing along special corridors. And the initial spread of the LBK from its point of origin or population in general already forms a network as they are spreading, which is like a personal network, a contact network. And this stands in reciprocal relationship to a whole number of different processes going on, but also very much with in relation to the raw material exchange. And raw material exchange that flows along this formed network can reinforce connections that are already present or form new edges. And this is the process behind what we see at the end as the distribution of the LBK in the space and the raw material. In terms of working steps, what we do, we overlay basically Europe with a very broad grid of 25 kilometers to 25 kilometers. And for every given time horizon that we are looking at, we are transferring at these pits, whether it is within a settlement area or what raw materials are present. And then we extract for each time horizon only the nodes that have information on them. So we then produce networks which can actually be compared to each other. What we see here is the grid nodes that we are using for the LBK, because it's either within a settlement area or additional information is therefore the spread of very specific raw materials, as we are only talking about sourceable raw materials. The data for these sourceable raw materials comes from another project which was running together with Tim Kehrens, the Big Exchange project, who was dealing with putting together a database of sourceable raw material distributions from the mid-Holocene with the beginning of the LBK up to the Roman times. You can see here a presentation of all the data sets that we brought together, and we are now using this down here, the LBK data set for the distribution of sourceable raw materials. So raw materials that we more or less know where they come from. What we are using is, on the one hand side, raw materials that, let's say, were used to produce everyday tools, like the Krakow-Jurassic or the Vacuum rhyolarites, and we are taking here the subgroup of what is called Sendgau, just then Abensberg and Hofenchurch, and of course the Reichholz, which were all data sets that are very readily available as they have been worked upon on a large scale to see how they spread into the area. And then we have these other raw materials that come from another sphere, like the spondylus shells that spread here across Central Europe or the Atlantic shelf, and also the actinide hornblende schist edzes. This data set here is, I will have to mention that, from 2008, as Katrin Morak has been putting them together, just so that you can assess the quality of that. Again, what it looks like, you have these nodes, which are the potential nodes of the mobility network that we are reconstructing. The raw materials are spread. And this is the result of the network, as we have these loose nodes, and they are connected either mathematically through a proximity-based approach, so nodes that are close to each other and have a higher possibility of being connected than nodes being farther away. Then the possibility or the connection rules regarding material distribution. If you have, on the one hand side, material nodes or regions are connected if they show the same material. So node A is connected to node B because they have, for example, Reichholz. What is important it is not the reconstruction of the exchange system. So it's not site A, region A gave to region B, because site A can also be together connected to site C, although the material flowed through site A. So it is a similarity network. It is in the belief that the exchange of raw material also exchanges ideas. So it's raw material spheres that we can see here, the potential connectivity. We also have the third connection rule. No, we have the connection rule of source to site, which is simple, but this is actually because we are manipulating the parameters of when to construct the edges. We say that only the sites which are very close to the source are connected to the source. This is different for hunter-gatherer societies. We have a little bit, we make that larger. And we have also the possibility, there's somebody wanting.
I have more.
Okay. To enter the room. We also have the possibility of source-to-source connection, but then again, this is for hunter-gatherer societies using an embedded procurement strategy, more important than for the LBK, so we are ignoring that rule. And what we can see in this graph here that we want to use, as I said, as a baseline for human migration, but they can also be interpreted in their own right. You can see this is connectivity, this corridors emerging here. I was interested, or I was really astonished of this really loose connection down here, because there is really not going on a lot here. We have only single connections due to the raw material, so we know they passed through there, but the density was very low here. What we can also see is the lack of data. For example, for the Paris Basin, we already are now adding information that we get from Pierre Allard. Also, this region up here is very low. It seems to be not very well connected, which of course which is not the truth. Terms for the migration modeling, it would be still reachable. So this is the important part. But when we now add the information that is not connected to this everyday use, and I'm omitting now these short connections, because we want to look at the grand of the bigger patterns emerging here. The picture changes, of course, a lot. This in the first view doesn't say us a lot. It looks very confusing, but through network visualization, we can really extract patterns out of these wild networks. Here is a very simple visualization through the calculation of modularities, which is a cluster calculation in terms, and the coloring of the emerging clusters. And you can see here what is coming out is this really big blue group, which is forming here, and this red wedge here, which is slowly developing. This is a general pattern that we also see when we start playing around with the data. So we have the same network here, omitting the edges between nodes that are only connected through one network, so which is the stronger connections, and this area gets even more isolated. I then played around with the granularity of the grid, making it smaller, but the picture always stays the same. You always have, what you can see here, if you make a smaller grid and remove the actinic hornbänder edges, as it is difficult to know if they really all came from the same source, as we have learned. It gets a bit more, you get smaller communities showing up in these large network representations, but it keeps being the same, that we have this this group here being more or less isolated from the rest. What does that tell us in terms of the bigger picture we were just looking at? I think what we might recognize here is something of a vulnerability of the region in terms of networks. So of course, we only see the final picture, but I do think that if you look at these networks and see how they are relying on very simple, on single nodes and single regions, if we have a degradation and an overstretching of these contact networks over time, that this might lead to a breakup of networks, and this regionalization that we can observe by the end of the LBK. We look at the data from the Rhineland. We might see some hints regarding that. So this is again the general curve of the settlement dynamics with the enclosures showing up here and the wooden wells. And now we see here the percentage of Reichhold and the percentage of adzes, actually Tornländische schist adzes in Kikofen, which is very far away of this region. So Kikofen is potentially in need of a network to get their raw materials. You can see how in the course of the time these amounts of adzes and Reichhold go down. And if you see these as an indice of a network, you can see that the connectivity goes down. At the end, if you take it all together, how does this position the Rhineland? The question that I have asked at the beginning. Of course, I can't give you an answer because it's archaeology and we can never give you an answer, a true answer. But I think what is important that if we look at these large-scale developments like suitability maps or these large-scale models like suitability maps or networks that span the whole of the LBK, you always have to keep in mind to also look at the smaller scale, and you can see broader patterns emerging there that might explain regionalization processes going on in terms of network. This is of course not my work alone, not at all. I'm merely standing on the shoulders of giants. This is the work of a lot of people in a whole bunch of projects that I've been working in, and I will thank them here at this point as I can't name them all. And this is the end.
Well, thank you very much, Johanna. It was a nice lecture. There is a lot of people who are interested in the